Hey Matt, coming at you with a response for your last video. Yeah, so, I guess let's get started. So a couple of responses to what you talked about in your last video. So actually, metallic hydrogen is a really important, more of like a material, I guess. So actually we have evidence of metallic hydrogen. Okay, let me give you a little bit of a background. So I first learned about metallic hydrogen, excuse me cat, I almost kicked him. I first learned about metallic hydrogen in an astronomy class. And actually this book does some interesting things about metallic hydrogen. And the joke here is, to astronomers, it's a metal if it's not hydrogen. Simple as that. That's what they say. So that's coming from my college astronomy professor who says basically if it's not gaseous hydrogen, it's a metal to astronomers' colleagues. So, and if it's metallic hydrogen, it's a metal. Just add it to the pile. So metallic hydrogen is prominent in all stars. It is a state of matter before nuclear fusion, but the pressure is just not quite there for nuclear fusion to occur. So, for example, Jupiter is a big old ball of not gaseous hydrogen, well, gaseous on the outside, but metallic hydrogen at the core. It's ultra dense. It's it's on the verge of nuclear fusion, but so-called brown dwarfs, which is what Jupiter is more or less a failed star. So Jupiter, if you compressed it even more and more and more, or on the other hand, dropped a bunch of mass into it, I think the number I remember was 80 times what Jupiter weighs, which is not that much when we're talking about celestial objects. Jupiter, and I've also heard of different numbers, 80 Jupiters, or 20 Jupiters, or 14 Jupiters. The one I learned in a astronomy class was 80 Jupiters. So you dump 80 Jupiters worth of hydrogen, cold hydrogen. We can get into that later. Cold hydrogen into Jupiter, and boom, you get nuclear fusion, a self-sustaining nuclear fusion reaction that will burn for a very long time because it's small. And I shouldn't say burn when I'm talking about it in a scientific standpoint, because obviously it doesn't burn. But that's a different topic. So I just say burn as in the use of fuel. And I think that's what most astronomers, most scientists, and most intellectually capable people will say or agree with me that when you say burning hydrogen, it basically means using the fuel. So metallic hydrogen is there on Jupiter, and it's just a weird state of matter that is kind of like, I want to say kind of like a condensate. It's highly conductive, as you say, and it gives us auroras. On Jupiter we get auroras, same with Saturn we get auroras, and of course by auroras I mean northern lights, or magnetic, stuff with a magnetic field. So that being said, I do find it interesting that they can make that actually. I have to read some papers on it because in my impression, and from my understanding, it would have been almost impossible on Earth. But so I'd like to read up on that and do a little bit of research, which brings me to my next topic. I've got a video here, which I will put in the video right here, which I find this to be amazing. I think I don't to me, I don't really know how to describe it other than, like, I can't believe what's ahead of us. I think the world of science and astronomy is so exciting because I can literally point to 4 planets that no one even dreamt existed even 10 or 15 years ago. So these are 4 exoplanets orbiting a star. This is a star system that is not in our solar system. So, I mean, obviously that's what that means. So, these 4 planets, I think over the course of a couple of years, they were able to take these pictures and make a 3 or 4 second video. So that's kind of cool. But it also tells you that, first of all, those planets are massive. They are Jupiter-sized planets. When they move that slowly, they've got longer orbits. Obviously, they're further out, and further out planets are always gas giants. Now, I'm not saying they have to be, but they are usually gas giants like Jupiter, Neptune, and that business. So anyway, I thought I'd do a little bit of a video on that, show you. I'll set up a link in the description of this video so you can go and check out the original thing of that clip. Anyway, I think that's really exciting. If they are getting closer to setting up metallic hydrogen, I think that's a good step in even nuclear fusion coming along. I mean, if they're trying to make a sustainable nuclear fusion reactor, they'll probably destroy the world, given the path they're taking. If they're playing with metallic hydrogen currently, they maybe are trying to make a star. A self-sustaining nuclear fusion reaction on the surface the size of a soccer ball would not only destroy my house, but I think it would destroy most of Salt Lake. So don't quote me on that, but that makes me a little nervous. So anyway, coming at you with another video. Just decided to make a quick response, and I'll get editing, and we'll keep going. Peace out, homie.